Uh, Question is majority element. Given an array nums of size n, return majority element. Majority element is the element appears more than n by 2 times. You may assume that majority element always exists in an array. Okay. So we can assume majority element will be must exist, and what is majority element means? The element that appears more than these n by 2 times. So n is the size of array. So if we see this is a nums and n is 3 and one element which is 3 that is appearing more than n by 2 times, this and this total 2 times 3 is appearing 2 times, and we see 3 by 2 it is more than appearing 1.5. So the majority element is appearing more than this time. So it means that 3 is the element that is appearing more than this time, 1.5 or simply one time. So if we see this example, 2 is appearing 4 times, 1 is appearing, if I keep this like 2 and count, 1 is appearing, here is 1 which is appearing 3 times, and if I see n by 2, n is here n is 7 7 by 2 would be 3.5, and which element is appearing more than this number of times. So if we see here, this is element 2 and 1, and this is the count they are appearing, and 2 is our answer in this case. So we have to find out the element that is appearing more than this number of times and return that element. So here 2 is our answer. So how we can solve this? It's like same approach showing here. Like we can have a hash map that keeps an element along with their count. So let's say if I run on this, we can check 2. 2 is appearing one time. Then we read again 2. 2 is appearing now 2 times. Again 1. So 1 is appearing one time. 1 is appearing now 2 times. Now it's again here 1. So 1 again is appearing now 3 times, and 2, now 2 is appearing 3 times, and again 2, and 2 is appearing 2 times, 4 times. And then we can, in between while checking, we can add a check, this check, how many times it is appearing, and we can add a check while we are inserting element. We can check which element is appearing fulfilling this condition, and the element that will be filling our this condition, we can simply return that key element or key. So this is a approach. We in this approach we need hash map, which will take our space of n. But here if we see follow-up question, there is a follow-up question. Could you solve this linear time and linear space of a constant space complexity? So to solve this in using constant space, how we can do this? Uh, we must need one thing. We know that there is a majority element, and we need one thing, that is which one element is appearing more than this time, like maximum count of element that is appearing, or maximum number of times like number of times that is appearing more, like maximum number of times that an element is appearing. It can be like count of an element that is appearing more than this number of times. And the second would be that element we need. The two things that we need in this case, and how we will validate, like this is appearing more number of times, this is the majority element. So the thing is, if we assume this element as our majority element and keep it in here, let's say 3 is our first element, is our majority element, and we have, let's say, count is 0. And if this is our first element, okay, then we need to track. If this is first is our majority element, then it means it means its count should be 1, because this is appeared at least once time. So okay, so if this is the element that is appearing once time, we can uh, add its count to 1, and count will be from 0 to 1. And we can add a check if, like how we will validate, like 3 is appearing in one time. So initially we considering this 3 as majority element, and if we are considering C is our count number of times this element 3 is appearing, which is 1. So it means majority element is 3, and this is appearing once time. So how we should move forward, and how we should make sure this 3 is the majority element, or any other element that is appearing in array is the majority element. So if we see here, 2 is our next element. So we know that the count is no more 0. There is some majority element which has some sort of count. And we know that this is majority element. We know this is our count. And we see now 2 is not same as 3. Both are different. It means there is another element that is appearing in an array. It means there is another new element, new candidate. There is new candidate that is appearing. So this can also be a majority element. This can be the majority element. So what to do now? We consider this 3 as majority element. So, and we have count of 3 as 1. We can simply do one thing. We can keep this 3 as majority element, and we can reduce this count to 0. Why? Because there was one count of this 3 majority element, and there is 2 count of like there is again another candidate appeared, which is not same as previous 3. So it means we can there is new element, new candidate appears. We can set it to decrement, like what to 0, because both are same. So we can reduce it to 0. And if this is the case, then we can consider simply our new majority element, because this can also not be majority element in these two elements. This cannot be majority element, and this cannot also be majority element in this case. So because both are appearing same number of time, which may not fulfill this condition. So moving forward, 3 is another element. So we know that there is no count of any majority element, and it means there may be a new candidate that fulfill the above condition. So if we saw that this count is 0, and it means we can again, just like we did here, we can again assume that our majority element is 3 now, and we can set its count to 1. And in the end, we can simply return this majority element. This would be our majority element, because there is no more element left now. So this would be our majority element. So if I run the same on the example 2 to see how it works, like to see how like this algorithm gives us a majority element. So let's see, trying to look on this two first, assuming count is 0 initially and majority element assuming as first element which is 2. Because count is 0, we can assume is it's there is no element that can be that is we have listed. We can assume then 2 is our majority element. So if this is the case, okay, then we can count uh, our, so it means now 2 is our majority element and which has count 1. So let's see, is there any candidate that is also again major like comes in category of majority element I consider. So if we see this, there is new element which is 2, new candidate which is 2, and which is same as we considered before the these two, which was majority element, and it means new element is also same as we supposed the majority element. It means this increment from this 1 to 2, because um, this is this is the majority element, and this is again same as we suppose. It means this is most probable we will fulfill this n by 2 condition. So and we can, if we see next element, new element that is appearing, which is 1, which is not same as we assumed the majority element, which is basically 2. So it means currently this element 2 is a majority element and which is has count as 2. Now if we see this 2 is a current element which is 1 and which is not same as this considered or assumed majority element. It means this there is a new candidate, we need to reduce its vote by 1. That cancelled by the new candidate which is 1. So its count is now going to be 1. So but majority element will remain same because this majority element has more votes than 1. So if we read again 1, and this has a majority element, this is the, if we see this is current element which is 1, and we have majority element again 2 which is not same as current element which is 1, and it means again we need to reduce this. There is a new candidate and that cancels this vote and we need to reduce this to 0. So in this case it means there this will these two twos and these two ones both are cancelling their votes, like both are two candidates and both have same number of number of votes, some same number of elements they are appearing, so that is why the count is 0. So in this case we need to update this 2 to the new majority element, but this will be updated when we have new vote, new candidate. So if we see there is a new value which is 1, and now we see there is count is 0. It means this cannot be the now no longer be the majority element will be new and that will be now 1. That is our new majority element, and the count for this would be 1. So again, reading this new element. So 2, which is current element, is 2 now. And if you see majority element, post majority element is now 1, which is not same as current element, which is 2. And it means new element or new candidate is appearing. And if new candidate is appearing, which is cancelling this 1, like to 0 because this has vote 1 and this was having vote 1 already in count. So this vote 1 cancels each other, so it reduces to 0. So now again this is 0, count is 0, it means we need to update our again majority element. So now majority element will be updated in next, when next new voter or next candidate will come to vote to specific candidate. So if you see, this is a new candidate which is 2. Sorry, this is the new candidate which is 2. If this is 2 and we consider that this 0, and we can assume this is our majority element, and this will be the 1 now. So because now there is no more candidates left, so this would be our majority element. Why, how this like solves this problem? Because uh, we know that there is one element that would be this number of times, at least n by 2 number of times. So it means if this is appearing most number of times, then it will remain as our majority element, even if there are a lot of other elements. For example, if there are 10 majority elements, let's say if there are 1 appearing 10 times, then after that 2 is appearing 8 times. And we know, we can by seeing this we can see that this 10 is appearing more than 2. So it means this would be majority element. So 10 minus 2, if we do 10 minus 2, it will automatic 10 minus 8, it will automatically give us 2. So same kind of thing happened here. If we see number of 4, total 2 is appearing total 4 times, and 1 is appearing total 3 times, and 4 minus 2, 4 minus 3 will give us 1, which is same as this count. So this is how it gives us the majority element. It's like a voting algorithm. The candidate, we can consider the element which this is 2. There are 2 candidates, 1 and 2. 1 and 2 both are candidates that are appearing in this array. So we just need to see which candidate has the more votes than the other candidate. So we know that this line states that there must be a candidate which has more votes than the other. So we can say that this is there would be a majority element. So these two candidates, from these two candidates, one has the 3 votes and 2 has the 4 votes. So it means this one is the winner. So that is why this algorithm comes solves this problem. Like this is how it solves, gives us majority element as 2. So this was the overall dry run, and this solves the problem in of n time complexity, and with space complexity, constant space complexity, because we are not using any memory, extra memory, just except from the variables. So we can keep 2 variables, count initially set to 0, and we can say that element as let's assume just element, I'm just initializing it as 0 minus 1. uh, then for every element in nums, and this would be our stop condition, and increment by 1. So we wanna find, so we know that if we need to check if there is no count of any element. If this is the case, then assume your majority element as nums of I. current element. Whichever the current new candidate is, just assume that this is your majority element. So if this is the case, if this is not the case, then check if current element, sorry, assumed majority element is same as current element, then it means you need to increment the count. Why? Because we checked, hey, if this is the voter, this is a majority element. We see this candidate is winning. Then we are saying current. If the current vote is of same candidate, then it means we need to add one more count one more vote for this candidate. So this will give us one more count of the current candidate, because this is the same as we considered. If this is not the case, else just it count by one. So if this is not same case, it means new candidate appears. Then we need to reduce the one vote of the candidate we considered is the winner or majority element. So we need to reduce the one count of this considered majority element by one. So if on learning loop there is again this kind of case comes, we will consider our new majority element. So this in the end our element variable will contain our majority element. Okay, sorry. So this is our majority element.